Hello everyone. Today we discuss about the units and dimension. In physics and mathematics, the dimension of a mathematical space or objects is informally defined as the minimum number of coordinates needed to specify any point within it. Thus, a line has a dimension of 1D because only one coordinate is needed to specify a point on it. For example, the point at 5 on a number line. A surface such as a plane or the surface of a cylinder or a sphere has a dimension of 2D because two coordinates are needed to specify a point on it. For example, both latitude and longitude are required to locate a point on the surface of a sphere is three-dimensional because three coordinates are needed to locate a point within this space. Two points can be connected to create a line segments, and two parallel line segments can be connected to form a square, and two parallel squares can be connected to form a cube, and two parallel cubes can be connected to form a trisket. Basically, dimensions are the powers to which the fundamental units are reached in order to express the derived unit of a quantity. Dimensions mainly the dimensions, seven basics dimensions we talked about, and that is the length is L, and mass M, time T, temperature that is in K or theta. Most commonly used are as length, mass and time. Electric current is electric current in ampere. Luminous intensity is in candela, and amount of substance is in the mole. Dimensions, dimensions of physical quantities. From the fundamental quantities we form the derived quantities also. um, Area, for the dimension of area, it is in meter square, that is length into length. So expressed in m naught, L2 and L to the power 2 and T to the power of 0. Volume, it is in meter cube, uh, mm, and that is length cube, m0 L to the power 3 and T to the power of 0. Mass density, that is the mass per unit length cube, m1 L to the power of 3. So m1 L to the power minus of 3 and T to the power of 0. Velocity can be also defined as the displacement per unit time, that is the length per unit time, L1 T to the power of minus 1. So in case of velocity, m to the power of 0. Acceleration is in change in velocity with respect to the change in time. So change in velocity, that is length per unit time into of change in time in t. m0 L to the power of 1 and 2 to the power of minus 2. Acceleration due to gravity, it is same for that of the acceleration. So force, for the force, force can be defined as the mass into acceleration. Mass is m1 and acceleration is L1 T to the power of minus 2. So the dimensions for the force is m1 L to the power 1 and T to the power of minus 2. Momentum is defined as the mass into of velocity. Mass into velocity is displacement per unit time, mlt1. M to the power 1, L to the power 1 and T to the power of minus 1. Pressure can be defined as the force per unit of area, mlt to the power minus 2 divided by L square. So m1 L to the power of minus 1 and T to the power of minus 2. Moment of inertia is also defined as the I is equal to m into of d square, m1 L to the power 2 and T to the power of 0. Surface tension is force per unit of length. Force m1 L and T to the power minus of 2 divided by L. So m T to the power of minus 2. Length unit, that is in the dimensions of force divided by length is cut down. So m1 L0 and T to the power of minus 2. Torque can be defined as the force into perpendicular distance. Force, the dimensions for the force is ml T to the power of minus 2 into L ml to the power 2 t to the power of minus 2. Stress can be defined as the internal force generation in the material divided by the cross sectional area. So mlt to the power minus 2 divided by l square, and the unit, the dimensional unit is same as that of the pressure, that is m1 l to the power minus of 1 and t to the power minus of 2. Strain is defined as the change in length divided by original length. So length divided by length, it is cut down, so it is a dimensionless quantity, such that refractive index can be defined as the speed velocity in one medium with respect to the velocity in the another medium. So it is also a dimensionless quantity. Mechanical advantages is also a dimensionless quantity. That mechanical advantage defined as the load per unit of effort. Work or energy. Work is force into displacement force mlt to the power minus of 2 into length of l, displacement for the length l, m1 l to the power 2 and t to the power minus of 2. Potential difference is the work done divided by charge. So for the charge is equal to I into t, current into time, and for the force work, it is force into displacement, mlt to the power minus of 2 l into a divided by t. Boltzmann constant formula for the Boltzmann constant is equal to pv is equal to kt. It is asked in the uh, JEE exams. For the ideal gas equations, it is pv is equal to nRT. For the Boltzmann constant, pv is equal to kt, and k is the Boltzmann constant, so pv divided by t. For the pressure, we define as the force per unit area into volume is area into length, and for the temperature, the it is in theta, mlt to the power minus of 2 l divided by theta. Planck constant, it is a proportionality constant, that is the energy is equal to h into f is the frequency and h is the Planck constant defined as energy per unit frequency. So energy, it is same as the work divided by frequency is 1 by time period. Work is equal to force into displacement divided by of time period, ml to t to the power minus of 2 and t to the power minus of 1. So gravitational constant is also defined as the gravitational constant is also defined as the force is equal to g m1 m2 divided by of d square. So g is equal to f into d square divided by m1 into m2, and g is equal to for the force mlt to the power minus 2 into for the distance square l square divided by m square. So g is equal to m inverse of l cube divided by t cube. Angular velocity is also defined as the velocity per unit of radius, that is velocity is displacement per unit of time. It is same as the unit of the frequency. Thank you.